The first thing that we're going to be graphing is this column here, circles. There's a list, a long, if we were to do all of these, which we're going to, but you see all these different rules and everything, rather than reading each and every one of them and going through that in detail, you can read those on your own. I think it just makes more sense if I explain it as I start actually doing it. So that's what I'm going to do. If we are going to graph for cosine theta, this one right here, let me show you what that looks like first on the calculator. It looks like that. Now, to me, that doesn't look like a circle because it looks like it's kind of smushed there at the northern and southernmost points, but it is. Don't let that get to you. Okay, for cosine theta. Now, whenever we're graphing circles, the number in front, that's going to be your diameter. That's going to be your diameter west and east. That's going to be your diameter north and south. If it's cosine, that means you're going to be graphing. Your graph's going to be symmetrical on the x-axis. And if you're graphing a sine function, that means it's going to be symmetrical on the y-axis. So let's do it. For cosine theta, I'm going to graph a coordinate plane here. Now, our diameter is 4, and it's also positive. So that means we're going to be symmetrical on the positive x-axis. What I'm going to do is I'm going to start by putting a plot at the origin. But wait, we don't call it origin because we're dealing with polar now. So that is the pole and not the origin, technically speaking. So what we're going to do now is from the pole, we're going to go 1, 2, 3, 4 spaces in the positive direction on the x-axis, and then we're going to plot, that's representing our dominant axis right there. And then we're going to go up 1, 2 spaces north of the pole and 1, 2 spaces south of the pole. Why did we do that? Because from here to here, the distance is 4, and that's what our diameter is. So anyway, now what we want to do is just do the best you can to graph a circle. Don't stress too much about it. Done. Okay, now we have r equals -3 cosine theta. Cosine, so we're going to be on the x-axis. -3, we're going to be on the negative x-axis. Plot the pole, 1, 2, 3 to the left. I'm going to go up 2, down 2, but our distance needs to be from here to here, which means whenever we draw, we want to try and be up at about 1.5. Whenever we're down here, we want to try to be at 1.5. But like I said, don't stress too much about it. Okay, so from the pole, we went 1, 2, 3 to the left. Plot, that's our dominant axis, and then draw your circle. I'm proud of that circle. I think that one's pretty good. Okay, r equals 4 sine of theta. Sine, y-axis, 4, positive y-axis. Pole up 1, 2, 3, 4. Plot from the pole, 2 to the left, 2 to the right. Do the best you can and draw a circle. Now right here, -2 sine of theta, sine y-axis, -2, negative y-axis. Pole down 2, plot 1, 1. Draw a circle. And we have now graphed circles. We're next going to be graphing cardioids. Think heart. Here's a list of features for cardioids. I'm going to explain it as we go. The most telltale sign that you're about to graph a cardioid is notice that the numbers are the same. This has 2 A values. They're the same. Don't let the signs throw you off because, hey, wait, that's 2 and that's -2. Okay, yes, but just look at the numbers, not the signs. They're all the same. So these are cardioids. Before we start graphing the first example, let me show you what a cardioid looks like. See, it kind of looks like a little heart, doesn't it? Isn't that nice? Let's get to it. Cosine, positive x-axis. Now we're going to start at the pole, but what we want to do is these 2 are A values. We want to add them together. 2 plus 2 is 4. 1, 2, 3, Now, plot dominant axis. We want to then look at this A value. Whatever that value is, that's how many you're going to go up from the pole. That's how many you're going to go down from the pole. And then we want our graph to cross those points. So I want to cross here at +2. I want to cross here at -2. And then just do the best you can to draw a heart shape. Beautiful. R equals to -2 cosine theta. Cosine x-axis. There's a -2 in front of cosine, so negative x-axis. Pole. Now, how far do we go away from the pole in the negative direction? We're going to add these numbers, disregard the sign. We're not doing 2 plus -2, just do 2 and 2. So we're still going to go for 1, 2, 3, 4. Plot, that's the dominant axis. That number tells us how much to go up and down in regards to the pole on the non-dominant axis. And then draw. That's beautiful. That's a good cardioid. R equals 2 plus 2 sine of theta, sine positive y-axis. Or I'm sorry, y-axis, +2 in front of it, so positive y-axis. Plot the pole. 2 plus 2 is 4, so up 1, 2, 3, 4. Plot the dominant axis, a value of 2, so we're going to go left of the pole 2, right of the pole 2, and then let's draw the most beautiful heart you've ever seen in your entire life. Let's go. I tried. R equals 2 minus 2 sine of theta, sine, so y-axis. -2 in front of that, so on the negative side of the y-axis. Plot the pole. 2 and 2 is 4, so we're going to go down 1, 2, 3, 4. Plot on the dominant axis. 2 is our a value, so we're going to go left 2 of the pole, right 2 of the pole on our non-dominant axis. That one's pretty good. I'm happy with that one. Okay, now we're going to start graphing this column. We're going to graph this column first, and we're going to graph limacons. Or another way I've heard it pronounced is limicon. So depending on how I feel, I might pronounce it one way or the other. Limacon or limicon. I don't know. Let's see. Now with limacons, look at the pattern. We have an A value, we have a B value, A, B, A, B, A, B. It's not always going to be 3, 2, 3, 2, 3, 2, or 2, 5. It's not always going to be that, but they're going to be different. That's how you can tell you're about to graph a limacon. Now, probably the most important pattern that you want to then try to look for once you've determined that your A and B are different is which value is bigger than the other. For column A, or for this column, this column here, the one that we're going to graph first, your A value is greater than the B value. When that is the case, here's what your limicon is going to look like. Okay, this is not technically a cardioid or a heart shape. This is more of like a dimple, and not so much that, you know, that nice little heart shape that we're accustomed to. So it's more dimpled. And then look what else happens. It's not touching the pole. It pulls away from the pole. So notice that. If A is greater than B, it's going to pull away from the pole when it's a limacon. So let's start graphing. Okay, cosine. So positive x-axis. I'm sorry, yeah. Cosine x-axis. Slow down, Flores. Slow down. Cosine x-axis. The number in front is negative. So we're going to be on the negative side of the x-axis. So in order to figure out, we're not going to plot at the pole here, okay? What we're going to do is from the pole, we're going to go to our A and our B values, and we're going to add them together. Disregard the sign. We're not doing 3 plus -2. We're just doing 3 plus 2. So from the pole, we're going to go 1, 2, 3, 4, 5 spaces away from the pole, plot our dominant axis. And now to figure out, well, how far away do we pull away from the pole? We're going to do the difference of A and B. So 3 minus 2 is 1. So we're going to be 1 away from the pole, and we're going to plot there. Now for our non-dominant axis, we need a distance of 3. So from the pole, we're going to go up 3. We're going to go down 3. And then just do the best you can to draw your limacon. Done. Okay, 3 plus 2 cosine theta. Cosine x-axis, positive 2, positive x-axis. A plus B is 5. So we're going to go 1, 2, 3, 4, 5 away from the pole. 3 minus 2 is 1. So we're going to go 1 away from the pole. A value once again is 3. So from the pole, go up 3, down 3, and then do the best you can. R equals 3 minus 2 sine of theta. Sine, y-axis, negative 2. We're going to be on the negative portion of the y-axis. Okay, 3 plus 2 is 5. So from the pole, go down 1, 2, 3, 4, 5. Plot A minus B is going to be 1. So we're going to pull 1 away from the pole. A value again is 3. So from the pole, go left 3, right 3, and graph. Ooh, that one's pretty good. That right there is a limaison. This one right here is a limacon. 3 plus 2 sine of theta. Sine, y-axis, positive 2, positive y-axis. From the pole, we're going to go up A plus B. So we're going to go up 5. 1, 2, 3, 4, 5. Away from the pole, we're going to go 3 minus 2, A minus B, which would be 1. I forgot my points. Plot. A value is 3. So from the pole, we want to go left 3, right 3, and then graph. That takes care of limacons if A is greater than B. Okay, now limacons. We're going to be graphing limacons again, but this time our A is going to be less than B. And here's what these do. Check it out. They produce a little loop-de-loo inside your limacon. That's what they look like. That's not really a good. See, you got to remember our scale here is it's really smushed and condensed. So this isn't, that's kind of what they look like, but they're more kind of heart-shaped a little. Okay, so here, once again, all of these are where A is less than B. Sine, so y-axis, positive 5, positive y-axis. Okay, now these are going to start at the pole. And from the pole, we want to go up A plus B amount. So 2 plus 5 is 7. So up 1, 2, 3, 4, 5, 6, 7. Plot dominant axis. A value is 2. So we're going to go left 2 of the pole, right 2 of the pole. Okay, now, how do we graph the little loop-de-loo? In order to do that, that's going to be A minus B. Don't worry about 2 minus 5, okay? Just 5 minus 2. That's 3, okay? So from the pole, we want to go towards our furthest most point, 3 directions, 3 steps, 1, 2, 3, okay? So whenever we do our loop-de-loo, it's going to start here, go there, and then come back, and then we'll continue the rest of the pattern. So here's what you do. Start from the pole, go to that dot there, come back, and then just swing it around. Come on, pen. Swing it around, bring it back, and then return. Like something like that. Okay, 2 minus 5 cosine theta. Cosine, x-axis. Negative 5 in front of cosine, negative x-axis. We're going to plot at the pole. We're going to go away from the pole, A plus B amount. So 2 plus 5, 1, 2, 3, 4, 5, 6, 7. Plot dominant axis. Our non-dominant axis is going to have a distance of 2 from the pole. So up 2, down 2. And now for our loop-de-loo, A minus B. A is 2, B is 5. Just think of it as 5 minus 2. That's 3. So from the pole, we're going to go towards the furthest most point, 3 spaces, and then plot. And now from the pole, let's start making our loop-de-loo. Boom. Okay. R equals 2 plus 5 cosine theta. Cosine x-axis. Positive 5 in front of cosine. Positive x-axis. Plot at the pole. The distance away from the pole that we need to go is A plus B. So that's 7 once again. 1, 2, 3, 4, 5, 6, 7. Plot. Our A value is 2. So on the non-dominant axis, go up 2 from the pole, down 2 from the pole. And now for our little loop-de-loo, A minus B, that's 3 once again. So from the pole, go towards the furthest most point, 3 paces, and draw. And now from the pole, go towards the loop. And then bring it around town. Bring it around town. If you can tell me what character that is. And by the way, that's not my best. I'm like way better at that impersonation, but I was trying to focus on 2 things at once. Tell me who that is and I'll give you a prize. And by the way, only one winner. So whoever gets to me first and tells me who that was I was trying to impersonate wins. 2 minus 5, sine of theta, sine y-axis, negative 5 in front of that, negative y-axis. Pole A plus B. So we're going to go down 1, 2, 3, 4, 5, 6, 7. Our A value is 2. So from the pole, we're going to go left 2, right 2. A minus B is 3. So from the pole, we're going to go down 1, 2, 3 spaces. I forgot my dominant. We're going to start our loop-de-loo from the pole. Oh my goodness, I just made a mistake. I'm sorry, y'all. Hang on, let me try and clean that up a bit. Sorry. Take 2. Okay, from the pole, we're going to go towards that dot, back to the pole, and then bring it around. And here, there used to be a axes there and there. Okay, there we go. Okay, and what we're going to be graphing last is rows. A lot of rules here. What we're going to be graphing first when it comes to the rows is we're going to be graphing if n is odd. We have an A value here. We have an n value here. If your n value is odd, which all of these are in this column here, that tells you how many petals your rose is going to have. The number in front, A, tells you the distance, the length, the diameter, whatever you want to look, or whatever word you want to use. Don't get caught on the terminology. Just that's going to be the length, okay, of each of these petals. Once again, try not to stress. Is it perfect? What about this? Just we want to have a close enough look at it. And before I get going, let me show you what this is going to look like on the calculator. Okay, now all of these roses, they're not going to all look the same. They're going to look pretty different for the most part. This is probably, like I said, the most difficult to graph just because there's so many different rules. But anyway, this is the one that we're about to graph. This is what this would look like. All right. Cosine. Now, if your rows, and by the way, if that is your n value is odd, if we're graphing a rows and we're graphing a cosine, that means one of your petals is going to be symmetrical on the x-axis. So let's do that. All right, so we've graphed our graph here. our length of each petal is going to be 2 spaces. So we're going to go 2 spaces on the x-axis to the right. Draw a plot there at the pole, and then just draw the best petal you can. And then we're going to draw, since we have 3 petals in this, we just want to do the best we can to space them out and make it look somewhat symmetrical across the other axis. Remember, if it's a cosine and your n value is odd, you're only going to have one petal only that is symmetrical on the x-axis. Okay, we have a cosine here. So we're going to be symmetrical on the x-axis. How many petals are we going to have? 5. You're right. What's going to be the length of each of these petals? 3. You're right. Let's graph. It's a cosine, odd n value. So we are going to be symmetrical on the x-axis. 3 paces. There's a petal. Now we need to graph 4 more. Just don't stress, do the best you can to draw 4 more petals in each of the quadrants. Boom. Okay, 2 times sine 3 theta. 2 sine 3 theta. These are not as easy, they're not necessarily hard, but it just requires an additional step than our cosine counterparts. If we're graphing a rose, and the way that we can tell, by the way, that we're graphing a rose is there's a number in front of theta. These are the easiest ones to identify. What are we going to graph here? Because it's the only one that has a number in front of theta. So we're about to graph a rose. Odd n value. If there's an odd n value and we're graphing a rose and it's a sine function, then we have to do a little bit more work to determine, well, is it going to fall on the positive y-axis or the negative y-axis? So what you're going to do is you're going to take the n value, which is 3, in this case, the one that we're about to graph, and we're going to multiply it by pi over 2. That would give us 3 pi over 2. So that tells us our petal is going to be symmetrical on the y-axis at 3 pi over 2. And in the event you don't remember where 3 pi over 2 radians is, it's right there. So we're going to be south of the pole. So here's our pole. Our petal length is going to be 2. So 1, 2. Draw your first petal. And then we need, we're going to have 3 petals here because our n value is 3. So we just need to draw 2 more in quadrants that make it look like a flower or a rose. 3 sine 5 theta. Our n value is 5, so we're going to have 5 petals here. They're each going to have a length of 3, but where is our petal going to be symmetrical on the y-axis? Is it going to be the northernmost side or the southernmost side of the pole? In order to figure that out, let's take our n value, 5, multiply that by pi over 2. That would give us 5 pi over 2. But wait, 5 pi over 2 isn't on our unit circle. Yeah, you're right, it's not. So let me show you how you can figure it out. Where is 5 pi over 2? Here's one way of thinking about it. One way you can think about it. Here's pi over 2. Here is, I'm sorry, somebody came in the room, had to take a pause. Let me go back. Okay, where was I? Here's pi over 2. You could think of this as 2 pi over 2. 2 pi over 2 reduces pi, by the way. This is 3 pi over 2. This is 4 pi over 2. This would be 5 pi over 2 if we started around the unit circle again. So this is where 5 pi over 2 would be. So we're going to need to graph our first petal up here, distance of 3. We've graphed 1 petal. We need 4 more. Just draw a petal in each of the quadrants. That's pretty darn good. Okay, and now we're going to graph roses if your n value is positive. Our first one we have here is 2 cosine 4 theta. Okay, well, how about we start with how many petals are we going to have here? If your n value is even, the pattern is, in order to determine how many petals are we going to have, is take your n value, in this case it's 4, and multiply it by 2. We're going to have 8 petals here. 8 petals. If your n value is even, what that means is you're going to have a petal that is symmetrical on every one of these x-axes. Or I'm sorry, on every one of these axes, more accurately. So our distance of each of these petal, our length is going to be 2. So from the pole, we go right to, up to, left to, down to. And we're going to start graphing 4 petals. 1, 2, 3, 4. We need a total of 8 petals, remember? Because n 4 times 2 is 8. So just do the best you can to draw 4 more petals evenly about the graph. All right, now 3 cosine 2 theta. How many petals are we going to have here? What do you think? In order to determine that, take the number in front of theta, which is 2, multiply it by 2. 4. We're going to have 4 petals. What is the length of these petals going to be? 3. Since n is even, since this is a cosine, that means we're going to have petals that are symmetrical across all of the axes. 1, 2, 3 is the length. 1, 2, 3. 1, 2, 3. 1, 2, 3. And since we have 4 petals, that means once we graph our petals along the axes, we're done. R equals 3 sine 4 theta. If your n value is even and it is a sine function, what that means is no petal is going to be symmetrical across any axes. In order to determine, well, how many petals is this going to have, we're going to take the n value 4, multiply it by 2. So we're going to have 8 petals. Remember, none of them are going to cross an axis. So we just need 2 petals in each quadrant. Each of them would have a length of 3 here, but don't stress too much about that. Just petal 1, petal 2, 3, 4, 5, 6, 7, 8. And then lastly, R equals 2 sine 2 of theta. Sine function, so no petal will be symmetrical about the axis. Our n value is 2, and 2 times 2 is 4. So we're going to have 4 petals. Each of them would have a length of 2. We have 4 petals. None of them are going to cross an axis. So just draw 1 petal in each quadrant. That's one of the best flowers I've drawn, the roses. Y'all, that is it. Now on the back of this piece of paper, there's a nice little practice thing. I recommend do it. It's matching. I think it could come in handy one day. I would work on that if I were you. That's it for today. Your assignment is on Delta Math.